Hello, this is Mr. Armstrong. Chapter 5, Completing the Square. Completing the square is used to find real roots of a quadratic by making a perfect square trinomial. We often use this method when the problem cannot factor or cannot factor easily. So, on the left-hand side, I've written down the steps. It's a good time to pause your computer and copy these steps down. When you're done, you can begin with example 1. Example 1, we have an equation, f of x equals negative x squared minus 4x plus 2. We take the quadratic and we set it equal to 0 and we get the x terms by themselves, which in this particular case means that I'm going to move the 2 from the left over to the right, giving me negative x squared minus 4x equals negative 2. Along with this step, we always have to make sure that a is equal to positive 1, so we'll divide through by what? Correct, negative 1, giving us x squared plus 4x equals 2. Step 2, we take the b value, the coefficient of b, which is 4, and we divide it by 2, quantity squared. So 4 divided by 2, or half of 4 is 2, and 2 squared equals 4. We add that to each side of the quadratic. We have now created a perfect square trinomial which can be factored. What are the multiples of 4 that can add together to give you 4? Correct, x plus 2 and x plus 2. We write it as a single quantity squared, and 2 plus 4 on the right side is 6. Step 3, we are now concluded. Step 4, we take the square root of each side of the problem, giving us two values on the right-hand side, positive and negative radical 6. The last step we do is get x by itself by subtracting 2 from each side, giving us a solution that x equals negative 2 plus and minus radical 6. We've attained two real, irrational, and unequal roots, which means that the original quadratic could not be factored. On the last page, I have another example. It's a good time to pause your computer and give it a try, and then follow through with checking your work. Step 1, set it equal to 0. Isolate the x terms. Make sure that a is equal to 1. So I'm dividing everything by 2. I now take half of negative 1/2 quantity squared and add that to both sides of the problem. I now have created a perfect square trinomial. I take the square root of this term and I get the square root of 1/16 as 1/4, giving me x minus 1/4 times x minus 1/4 squared. On the right hand side, 1/2 plus 1/16 is 9/16. I now take the square root of each side of the problem, giving me x minus 1/4 equals the square root of 9/16 is 3/4. Finally, I add 1/4 to each side. In this particular case, I have like terms. 1/4 plus 3/4 is 4/4, or 1, and 1/4 minus 3/4 is negative 2/4, or negative 1/2. This solution has given me two real, rational, and unequal roots, which essentially means that the original quadratic was factorable. Keep practicing, keep at it, and come on in for extra help.